All right, so what we're going to look at today is, well, before we get started, are there any questions over the homework? So what we're looking at are solving these here. Now, I believe I talked about this yesterday. Whenever we're solving these logarithms, where we have logs and then a number outside of the log, we need to simplify the logs to 1. We need 1 log equals everything else. Now, one of the properties that we have, whenever we have 2 logs being added together, I can rewrite this as a single logarithm with what's inside being multiplied together. So what we can do is rewrite log of 2x plus log of x minus 5 as log of 2x times x minus 5. Any questions on this so far? Now we can go about solving. Now it's not written in, but it is understood that the base of a log, when it's not written with log, is 10. So what we can do is put both sides to the base of 10. Because 10 log base 10, this here will cancel out, leaving us with 2x times x minus 5 is equal to 10 squared. Now at this point here we can distribute the 2x. 2x times x is 2x squared. 2x times negative 5 is negative 10x. And lastly, 10 squared is 100. We could, because we could subtract the 2x squared, then add the 10x, or we can go the other direction and just subtract 100, because we do need to get this equal to 0. Now at this point here, we could try graphing or factoring. Which one do we want to do? Graphing. So we can grab the graphing calculator. Y equals, clear this out. So we have 2x squared minus 2x, not 2x, what is it? 10x minus, and hit graph. Well, we do see that it crosses the x-axis in 2 spots. And if we look at the table, one of the locations is, so it's telling us that x is indeed equal to negative 5. So these are our 2 solutions. Now we do need to plug them back in to check to see if either one of these is an extraneous solution. It does not work in the original problem. Now the first one we can try plugging in is negative 5. So we'd have log of negative 2 times 5 plus log of negative 5 minus 5 equals 2. Now negative 2 times 5 is negative 10. And negative 5 minus 5 is negative 10. And one of the things we did say about logarithms is when we plug a number back in, I cannot have a negative inside of the log. Since we simplified it down and got negative 10 in both spots, it's telling us that x most likely, because there's nothing that's offsetting that negative. Now, if it had been, say, negative 2x and some way to make this be positive, then it would have worked. But for this here, negative 5 does not work. Now we can try the same thing with 10. So log of 2 times 10 plus log of 10 minus 5. Well, 2 times 10 is 20. And 10 minus 5 is 5. is equal to 2. So 20 and 5 are both positive and not 0. So what's inside of the logarithms? We can't take a logarithm of 0 or a negative number. But this here does work. Now we can look at log of 20 plus log of 5, and we should get 2. We do indeed so. X equals 10 is the correct answer. That's the one that works. Now it is possible to get negatives with it. It's just we need a way to offset those negatives in here. Does that make sense? We can look at one more of these here because I feel like doing probably one more of these should be good. We get kind of the concept, because the only real difference between what we're doing today and what we did yesterday at the end is just turning these two logarithms into one. So here, those two logs that are being added together, we can rewrite it as a single logarithm with what's inside being multiplied together. We can put both sides to the base of 6. Right. Our 6 and log base 6 here will indeed cancel out, giving us 6x times x minus 1 is equal to 6 squared. Now 6x times x would be 6x squared. 6x times negative 1 is negative 6x. You're good. Is equal to 36. Now at this point here, we need to get this equal to 6x squared minus 6x minus 36 graph. We have two spots where it crosses the x-axis. One of them is at negative 2 and the other is at
2. Wait, is that 2 or 3?
3. Negative 2 and 3. Now, one of the things with solving quadratics, we normally said if the number in front of x squared was different than 1, it's going to have fractional exponents, yes? But is there a greatest common factor between 6x squared, 6x, and 36? So really, this would become 1, this would become 1, and this would become... So because of that, it works out we could graph it and we're fine. Most likely, which one's not going to work? Negative 2. Because if we look at these here, neither one of these 6x or x minus 1, is there a chance that the negative 2 is going to somehow give us a positive number? Because if we did log base 6 of 6 times negative 2, I don't even have to write the rest. This is going to become log base 6 of negative 12. It doesn't matter if the other one was a positive number. If we have one that's a negative inside the log, it doesn't work. Now I can go on and do the rest of it, because we'd have negative 2 minus 1 is equal to 2. Because we have log base 6 and negative 12 plus log base 6 and negative 3. This doesn't work. And if we did do the same thing with 3, we would see that it does work. We have log base 6 of 6 times 3 plus log base 6 of 3 minus 1 is equal to 2. Log base 6 of 18 plus log base 6 of 2 is indeed equal to 2. So that is our answer. Questions on any of this here? Questions on anything we've done so far? How do we feel about multiplication, or with these additions of logs? Well, we're also going to look at 2 logs being subtracted. Now again, just like before, since we have 2 logs, multiple logs, and then a number that doesn't have a log, I need to get these 2 logs condensed down into 1. Now, whenever we add 2 logarithms, we can rewrite it as a single logarithm with what's inside being multiplied. If we're subtracting 2 logs, we would simplify it down to 1, but what's inside would be 1. So if addition was multiplication inside, what would subtraction be? Division. Now our base is understood to be, so we can put both sides to the, because this here will cancel out, leaving us with 3x minus 2 over 2. Now normally on all the previous ones we wrote 10 to the third, but what is 10 to the third? 10 to... Yeah, because 10 times 10 is 100, times 10 is 1,000. Now at this point here, we do need to get x by itself by 2, because here the 2 and 2 would yes. Three x is equal to 2002. Will it divide evenly? So we can just leave it as 2002 over 3. Now most likely this one's going to work because it is positive. Now if I plug this back in, we'd have log of 3 times 2,000 over 2 minus 2 minus log of 2 equals 3. Well, that should be 3. Here, the 3 and 3 would, giving us log of 2002 minus 2 minus log of 2 is 3. Really, we have log of 2000 minus log of 2 is equal to 3. Now we can plug this into a calculator. I can say log of 2000 minus log of 2, enter, we get 3. So,
Is it because it's on this calculator?
it should work.
Log of 2000 minus log of 2.
So you'll need to put the parenthesis. Because what it saw without that parenthesis, yeah, it said log of essentially 2000 minus log of 2, and those are contained with each other. It subtracted log of 2 from 2000 and then took log of it. So we do need to be careful with the parentheses and how we put them together. But that's it with this here. Now we didn't get 2 solutions because the degree of x that we had with this is 1. Any questions on this here? We good with this here? Yes? We'll look at one more and then we are actually done with the notes today. Now again, we have two logs that are being subtracted, so we can rewrite it as a single log with what's inside being. So x over x minus 1. Then we put both sides fourth. These here would 4 to the so 4 to the 1/2 is, because the 1/2 exponent is the same as saying the square root of 4, which is we multiply both sides by x minus 1. Or just 2x minus 2, yes. Yeah, we could subtract the 2x. Now, we could have added the 2 and then subtracted the x and got to the same spot. If we subtract the 2x, we get that negative x is equal to well, we get negative x is equal to negative 2. Divide by negative 1 and we get x is equal to 2. Because we could have added 2 and then subtracted x and got x equals 2. Now if we plug 2 back in, log base 4 of 2 minus log base 4 of 2 minus 1 equals 1/2. Well, log base 4 of 2 is actually 1/2, because log base 4 of 2 is the same as saying 2 to, or well, back up. 4 to the x is equal to 2, so it's 1/2 because it's square root, minus, well, this is just saying log base 4 of 1. Well, anytime we have 1 inside the logarithm, well, we're just saying 4 to what power is 1? Well, the only way that we can get that is if this is 0. So we're saying 1/2 minus 0 is 1/2. Or we could have plugged it in a calculator and it would have told us that that was true. Questions on any of this here? And that's it.